Okay, I'm going to make a little video to show you how to do those two applications. One's motion and one is area. So first, the equation we're going to utilize is h equals negative 16t squared plus vt plus c. This is for all of the objects that go up and then come down. So h, that's going to stand for height. T is time, that's in seconds. And the height, by the way, that's in feet. And this is in seconds. And then the v is the initial velocity of the object, whether it's hit up or shot up, whatever the case may be. C is the starting height or initial height, same thing. Starting height of the object. Okay. So let's look at an example. So we have this star that's projected from a firework, starting height 520, vertical or upward velocity is 72. So again, we just throw the numbers into the formula. So we have h equals, it's always going to be negative 16t squared because that has to do with gravity, the acceleration of gravity. Then the velocity is just going to go right in front of the t, so plus 72t, and then plus the 520. How long will it take the star to reach its maximum height? So then we would just find that we need to find the vertex to answer both of those questions. So we're going to go t equals negative b over 2a. So the opposite of b, so negative 72 over 2 times negative 16. So that's negative 72 divided by negative 32. And you can just grab a calculator for that. 72 divided by 32. So 2.25, so 2.25 seconds is when it reaches its maximum height. If you want to know what that maximum height is, then you just take the 2.25 seconds and you plug it in, and that will give you the height at that particular time. So negative 16, 2.25 squared plus 72 times 2.25, and then plus the 520. And so that's just a matter of plugging it into the calculator. So give me a sec to plug that in. So 601, so 601 feet. And if you put those two together, the vertex is 2.25, and then the y-coordinate is 601. You don't have to graph these, but if you did do a super rough sketch of the graph, it would look like this. It would start off at 520, it would go up, and then it would come down, and it would reach its highest point right there at 2.25. 601. Okay, next one, a similar deal, so vertical motion. So we have an upward velocity of 48, we have a starting height of 4, so we go h equals negative 16 t squared. So that initial velocity is 48. So we put that in right for the v, and then the c is 4, so just plus 4. When will it reach its maximum height, or how many seconds will that take? So that's negative b over 2a. It's the first part of the vertex. So the opposite of b is negative 48 divided by 2 times negative 16. So plug that in the calculator. 40 divided by 32, so 1.5 seconds. It's actually two negatives, which makes it positive. And now we can just plug that 1.5 into the function and see what the height is. So let's check it out. So negative 16 times 1.5 squared plus 48 times 1.5 plus 4, 40. So it reaches a maximum height of 40 at 1.5 seconds. Alright, so that's the vertical motion type of problems. Okay, so now the area. So we have 120 feet of fence, and that's going to cover 3 different sides. So these are the 3 sides. The house is going to be the other side. So this is the house, and I'm going to label the sides a little bit bigger. So this is X, and then the third side is when you have 120 feet, and then you take away X and take away X, it makes sense that the other side is going to be 120 minus X and minus X, which would be labeled as minus 2X. So those are your 3 sides. So the length, an algebraic expression for the length, is 120 minus 2X. Write a function that models the kennel's area. Well, we know the area of a rectangle is length times width. So we're going to say length times width. And so the length and width, if we multiply them together, one of them is X and one of them is 120 minus 2X. So just multiply those two together. And I just swapped them, so the 120 is the length and the width is the X. So then you can distribute, just so you get a nice expression. So distribute this, so that would be 120x minus 2x squared. And that's a function that describes the model's area. Okay, it says, what dimensions produce a kennel with the greatest area? So now we go back to our function, so it's a of x equals 120x minus 2x squared. And it's easier if you just put it in the order that we're used to. So we have minus 2x squared plus 120x, so that's easier to tell what the a, b, and the c are. So now we just need to find the vertex. So we're going to go x equals negative b over 2a. So the opposite of b, so that would be negative 120 over 2 times the a, which is negative 2. So we have negative 120 divided by negative 4, which is 30. So that means that 30 is the width, that's the x. And now if we want to figure out the maximum area, we could just do one of two things. We could just plug the 30 into the function, which is one way to do it. So we can do that. Or we can find the other dimension, which we need to do anyways. We need to find the other dimension. So the other dimension is, again, labeled as 120 minus 2x, and now that we know that x is 30, we can just plug the 30 in there. So 120 minus 2 times 30, so 120 minus 60 equals 60. So the length is 60 feet, the width is 30 feet, so the rectangle looks like this. And it has 30 here, and it has 30 here, and it has 60 there. And again, the house. So the question on the last one is find the maximum area of the kennel. So if your dimensions are 30 feet by 60 feet, those are the dimensions, then the maximum area is just multiplying those two together. So we have 30 times 60 equals, and that's 1800, and since it's area, it's square feet. Feet times feet is square feet. So 1800 square feet. And of course we'd get the same answer if we take the a of 30 and plug it into the function. That's what we would get. You don't need a graph on this, but the graph looks like this. It would be 0, 0, 0. If you plug in a 0 into that function, you get 0 area. And then we figured out that our vertex is right at 30. So that's 30, and then we figured out the high point is right here at 30, so that's 30, comma, and the y-coordinate would be 1800, so that's the maximum area. And then it hits here at 60, which means that if we let our width be 60, we would have no area, because we wouldn't have any sides left for the other, we wouldn't have any fencing left for the other sides. If that was 60 and that was 60, that'd be 120 and there would be nothing left for that side. Okay? The last thing that I want to do is just kind of show some answers to the homework on this. So here's the work. You just plug your 40 and your 6 in there. Do the negative b over 2a, so you get 125 or 1.25 seconds, and then plug it back into the function to get the maximum height. Next one, same thing, just plug it in, and you get negative b over 2a. It turns out to be a decimal. Plug that decimal into your calculator, and you get about 19.14 feet for the maximum height. The area one, they go ahead and give us the area function, and so we just need to find the vertex of that, because that's the max, that will give us the maximum dimensions, or the max area. So we do the negative b over 2a and we get 20, and then you can, if you want, this time I put the 20 into the function to get the maximum area. So this is 20, and if you wanted to find the other side, then it's, let's see, it's just, so if one side is 20, and this side is 20, then you have to use the other two sides, and it turns out the other two sides are also 20. And so, because this time we have all four sides that we're working with. Just a tip, whenever we're looking to maximize our area, whenever we have all four sides to work with, it always turns out to be a square. And a square is a form of a rectangle. Not all rectangles are squares, but all squares are in the subset of rectangles. Okay, this time we have one of the sides that we're using a river as one of the sides. So we only have 3 sides to work with. So this one's more like the example that I just did. So very similar, pretty much everything the same. And we find the maximum, so we do negative b over 2a. We get one of the dimensions should be 50. And then if we want to find out the other dimension, then we can plug in 50 right there. So it's going to be 200 minus 2 times 50. So that's 200 minus 100, which turns out to be 100. That's where that comes from. And when you multiply them together, you get your maximum area, which is 5,000. And another problem, same deal. You want to, there's a picture that you label the width x, and then if you have 50 feet of fencing, it's always going to be 50 minus 2x for the other side. and then you can see the work same after you write your function. Then you do negative b over 2a. This time the width is 12.5, and then we can plug in the 12.5 again right in for x. So we get 25 out of that. So multiply the two together, and that's your maximum area. Okay, this is the sheet from the sub. So these are just some terms. More terms, axis of symmetry down here, solutions. So the solutions are wherever the graph crosses the x-axis. So these are the solutions. And then the y-intercept, that's easy to find. You just plug a 0 in for all of the x's, and then that turns out to be 3. It's going to be whatever the constant is. So that's 0, 16. And then this one is a little bit different. We create the function based upon the starting velocity and the height, and then if you want to find out how long it's in the air, then that will be letting the h be 0 and trying to figure out how long it takes before the height turns out to be 0. And that's using the graphing calculator, so you do have to plug it in and press graph, and then you have to calculate the zeros. So I'm going to have to show you that in class. But yeah, so you're going to have the graphing calculator handy dandy for that one. But just so you know what you're looking for where it crosses the x-axis. And same thing here. First you're doing the vertex, so negative b over 2a, answering those same questions from before, and then how long will the ball be in the air, or / when does it hit the ground? So that's letting the height be 0, and then again using the graphing calculator, and you're looking for that point where the height turns out to be 0, which is why we're calculating the zeros. And that should be it. Alright, hopefully that helps you.